And I think maybe people noticed in that animation that the most observations we get from CERES are over the poles where there aren't very many people. So the students do help us fill in areas where we get fewer observations. Kory, let me now turn to you, and can you tell us a little bit about the CERES instrument itself and how it works?
Sure, I'll give you a little bit of information about the CERES instrument as well as the satellites or spacecraft that we fly on. CERES, we currently have 4 instruments on orbit on 2 separate satellites, and we have a 5th instrument which we hope to launch in 2011. The satellites or spacecraft that we fly on are about the size of a school bus. To give you a relative size, they're fairly large. And as Norman mentioned, they fly at an altitude of about 705 kilometers or about 420 miles, and it takes 90 minutes to circle around the Earth once. And over a day, we circle the Earth about 14 times to get us to complete global coverage. The CERES instruments themselves are one of about a half a dozen sensors that fly on each one of these spacecraft. As Norman mentioned, we fly 2 instruments on NASA's Terra and NASA's Aqua spacecraft. Each of the CERES instruments, I'm not sure if you can see this very well, but there's a model here. The instrument will fit in a sort of a moving box. It's about 2 feet per side. It's not a very big sensor at all. It weighs about 100 pounds or 50 kilograms and uses less energy than your typical light bulb. It uses about 50 watts of energy, and your typical household light bulb is anywhere from 60 watts to 100 watts. So within each of the CERES sensors, we have 3 telescopes. As you can see here, 1, 2, 3. They're each about the size, the telescope aperture is about the size of a quarter. They're really quite small, about 1 inch across, and they sense the amount of reflected solar energy and emitted thermal energy from 400 miles away up in space. And they work very much like, you've probably used a magnifying glass on a summer day to collect the sun's energy and focus it on a spot and maybe start a campfire. The CERES telescopes work very similarly. They have optics on the front end that collect the reflected solar energy and the emitted thermal energy, and they focus it on a small detector that's about the size of a grain of rice. And by scanning back and forth across the surface of the Earth in this fashion, they can go from limb to limb and get complete global coverage over a day. The spacecraft then collects this data, stores it on essentially hard disks on the satellite itself, and then every orbit it'll fly over a ground station where it'll transmit the information back to the Earth, and then it enters into the ground network, and that data eventually comes back to NASA Langley Research Center, where the scientists here can use the analysis to determine with CERES data the effects of clouds on the climate system.